Now we know from experience, when we drop an object from a cliff, it's going to start picking up speed, and that's because of gravity. We know what the acceleration is. We know that the acceleration for any object in a free fall, and keep in mind, we're not worried about air resistance, so we're assuming it's a small, dense object where air is going to have very little influence on it. So for that assumption, we're going to say my acceleration is the acceleration due to gravity, which we know is negative 9.8 meters per second squared. And again, it's convenient to think of that as negative 9.8 meters per second every second. Your velocity is going to change by negative 9.8 meters per second each second. And we want to know how fast it's going 1 second later, then 2 seconds later. Now, if we drop an object, we can assume your initial velocity is 0. So sometimes you got to read between the lines when you look at these questions. So dropping, we know initial velocity is 0. So it's starting at 0 meters per second. Now, 1 second later, it might be somewhere down here. It's picking up speed. Well, if its acceleration is negative 9.8 meters per second each second, we know that your velocity 1 second later will be negative 9.8 meters per second. That's the definition of acceleration. Each second, your velocity is changing by negative 9.8 meters per second. So if we add another second, it'll pick up another negative 9.8 meters per second. So its velocity 2 seconds later, it was going 9.8. It's going to add another 9.8, another negative 9.8. And my total velocity will now be negative 19.6 meters per second. Every second, I gain another negative 9.8 meters per second worth of velocity. So 1 second later, it's going negative 9.8 meters per second. 2 seconds later, it's going negative 19.6 meters per second.